Hi from me. I hope you can hear me well. My name is Bojan. I'm co-founder of StorPool, and we currently help public and private cloud builders to have a fast and reliable storage service, and therefore fast and reliable public or private cloud. Prior to StorPool, I have founded a number of companies, and I've also worked in other companies, big and small. And my background is mostly in IT and also a bit in finance. But with that short intro, I'd like to jump straight to the topic. And today we're going to talk about how you can differentiate if you're a cloud provider in the sense of building a public or private cloud, which share the same technology. They just have a different set of users. One is internal type of users. The other one is the wide audience who is buying cloud services from, in the case of cloud service providers. We will focus on how to build a fast, reliable, and cost-efficient service on the high level. So we'll show how a good storage solution has an impact through the whole IT stack. It touches network, it touches compute, and it can influence the reliability and cost structure of the entire cloud. And basically, we will present a proven storage solution that is implemented in a number of companies, which can help you achieve your company business goals. It's not about just the technology, it's how this technology has an impact on your entire offering or your entire business. So if you want to build a cloud, you have to build a better solution than what is currently possible. Otherwise, you will not have a competitive edge. And a big part of building a competitive service is innovating and delivering a number of different things you can, like technical parameters of your solution. And the first one is obviously faster service, which is the usual complaint of customers. The usual thing you see on support tickets is my service is not fast. The other thing that is, we call it feature number 0 because a lot of people avoid talking about it, but it is making sure that your service is up and running all the time. And it's not something fancy, but it's a must-have for any public or private cloud. The other thing that companies do to innovate and provide better service and differentiate their business from the pack is adding more features. And this is something that doesn't relate to storage alone, but to anything that you do in the business. And obviously, all these things that you do have to come at a competitive price, so you're not out of the market with your pricing. So for the companies that have to build a cloud and they cannot rely on external public cloud services for a number of reasons, either they want and require full control, they have to have the data in their data center, they need lower cost or more predictable performance, or performance that is higher than what is available in public clouds. There are a number of considerations why you would have to build a private or public cloud by yourself. And in most cases, you have to manage infrastructure that is, see something. So they made me a note that maybe you don't see the slides right. So let's try to figure that out. Are you on the right side now, or do you see it?
Yes, we should be on the right side. We're sorry for the short interruption. Just we want to be sure that you see everything on the slide, so the information is visible for you.
I'll do another, let me see. Maybe you see me now, and I'll do share entire screen, so that should be better now. Hopefully you see the slides now.
No, Boyle, unfortunately we don't see the slides, but we can see you pretty clear. As people say, these are the challenges when you make live stream.
Okay. Let's see now.
Okay, now we can see perfectly the slides.
What about now?
No.
That's an interesting one. So maybe, do you see them now? No? Okay, you see them now, I guess. So just a second, because there is a delay, obviously, on the...
Meanwhile, once again, I can encourage all of you to introduce yourself on the chat, and if you have any questions, just write them down.
Okay, so now it's all good. Now it seems to be working fine. So we covered how to differentiate if you're building a cloud, how you want to build a fast and reliable service, and how a storage solution would help deliver on your company goals. We also spoke about how you have to constantly innovate, so you're leading in your business segment. And one is the faster service, the other one is eliminating downtime. You have to add more features, and it has to come at a competitive price. I'm just basically recapping the slides because it seems you haven't seen them. So should be all clear now. So for the companies, as we said, companies that cannot go in public cloud for a number of reasons, they have to do the hard thing and manage their infrastructure. And for anybody who is managing or building infrastructure, they know that this is complex, time-consuming, and usually quite expensive. And here is what is important for the business. It's all the services that are running and are mission critical, and we just listed just a few of the services like email and your website, your test dev environment, your databases. And these are all the workloads that are key for the business. And you would run this if you're a private cloud, and if you're a public cloud, you deliver resources so other people can run their emails, their websites, their databases, etc. And if you're the company that's building the cloud and managing the cloud, you have a lot of other things that you have to take care of. And in most cases, like 80+% of the cases, we're working in a virtualized environment. So we have to take care of the virtualization layer, which is hypervisor. And if you have the scale, that's a cloud management system. Then have operating systems. Then you have the physical layers of servers, network, storage, up or down to the data center level. And on top of that, your business has to take care of all the services that make this thing possible, or the service possible. And this is design, the service built, buy hardware, rack it, install, support NSLAs, high availability backup, software updates, hardware refresh cycles, disaster recovery, DDoS protection, and all these things that are part of the running your own cloud game. And I think people don't realize, but the storage layer is one of the fundamental layers of IT infrastructure. And we are showing a screenshot here of the system of a particular customer that we have, because we think it will visualize it or get the message through. And here we see the latency, in this case, of a MySQL database that's running on a storage solution. And basically, we had a latency of about 1 millisecond, a bit less than a millisecond on average. And we had customers complaining that the service that they had is slow. And in many cases, this could be a cloud hosting provider. It could be an internal private cloud user that has an application that usually has a database inside. If you run a WordPress site, or if you run a CRM or anything, pretty much any application would hit a database underneath. And for these applications, it's not IOPS that you're getting, or megabytes per second, or CPU. Usually it's the latency of the storage system that defines how happy your customer would be and how fast this workload will go. And here we had a storage system that was running on a storage system that was not that efficient, and we helped this. This is a Swiss cloud service provider in this case, and we basically helped them by a couple of optimizations to push the latency of the system about 10 times, to reduce the latency about 10 times. So the average latency went down to about 50 milliseconds for this MySQL. It's obviously a big part of it. The biggest part is storage and also some caching algorithms on top. So this basically solved the pain point of the customer. And this basically made the workload run much faster. So by optimizing your storage layer, you basically unlock the potential of your entire IT stack, because usually the bottlenecks currently, for the most part, are in the storage layer. It's usually latency. In some cases, it's also balancing the throughput of the system, of the storage system, with the throughput of the client side or the hypervisors, the compute nodes. So basically balancing this through the network. But the storage system is usually the main bottleneck of a cloud, be it public or a private cloud. Another thing that we see a lot is people are having downtime, and we have a slide here that basically describes how to prevent downtime or how to improve your infrastructure layer. And a common theme that we see is companies using local storage solution. And unless you have a shared storage system, you will not be able to eliminate downtime. Because anytime that you have to take down servers for maintenance or upgrade software versions, patch kernels, or anything of that sort, you're basically bringing down the system. And unless you have a shared storage system that would deliver live migration and high availability, you would not be able to get rid of downtime. I think if you have a distributed storage solution, that would bring you even higher level of reliability, just because it has better redundancy. Like the distributed architecture is just inherently more reliable by design and more resilient. And also it has the self-healing functionality that prevents or helps you from or protects you from hardware failures, and it can get around those failures. Another big thing of deploying a proper storage solution is that all maintenance, all upgrades are online. So you don't have to restart service for anything that's hardware or maintenance related. Hardware failure or refresh of hardware, again, without downtime. You have high availability and live migration storage features working in concert. And this basically means that if you have workloads running on one physical server, you can basically live migrate and power the same workload on a different physical server, and you would have all the data sitting on the shared storage system. And unless you have a shared storage system, you will not be able to have uptime on hardware failure on compute side. Another thing that's crucial for your private or public cloud is scaling the system. And your ideal solution would have a small starting point where you can put the foundation, the layer of your cloud, but then it will seamlessly scale as your business scale or as your demand for capacity performance grows. So nowadays, scale out is the norm. And if your system still requires scale up and painful live migration of databases to a bigger storage system or to bigger compute instances, you have to consider innovating on this side. Scaling should be online without disruption to service, both in performance and in capacity. And here we've seen, for example, banks that have a 5 terabyte database running, and their database is becoming too big, and they have to put a new system in place, but then they have to go through the painful white migration of a production database that's running 24/7, and they have to get a forklift in a data center, forklift upgrade, they have to white migrate the data, and that's very painful. Ideally, you would not you don't have to experience this pain, and there the technology is currently available for you to have a system that just grows underneath your workloads without the workload sensing it and without any disruption. So this is kind of expansion of the previous point, but anything in your storage system, in your cloud, should be online. This is from expanding and shrinking volumes, white migration of workloads, the high availability in case of a hardware failure of the compute instances. Everything should be online. So again, coming back, there are ways to do this on the software layer, on the application level. Sometimes this is the more meaningful way to do high availability. In most cases, you do this both in the application level and in the infrastructure level. And when you talk about high availability, when you talk about online expansion and scalability of the system, a lot of this is done in the infrastructure level and in the storage system. And it touches the storage system in one way or another. So the thing that we've designed, and we'll show you this design now, is extremely fast storage system that unlocks the potential of your public or private cloud and comes at a very competitive price, so your business case also works. In this case, we're using standard Intel x86 based platform. So you take standard servers, which avoids, reduces vendor lock-in. In this case, we're using fast and efficient block level software-defined storage solution that stands for SDS. And this is, in our case, we're using StorPool. You're free to use any other solution. I think just StorPool is the fastest block storage, taking the least CPU and RAM. So this basically gives an extra edge to the business case. I mentioned that we reduce vendor lock-in. We'll show performance that, like the smallest system, the system that we are showcasing here, it faster than almost 500,000 IOPS and 200 microseconds of latency, and we'll show the impact of this in a later slide. This also reduces the total cost of ownership for public or private cloud by also optimizing compute side, by introducing single network that's only standard Ethernet, so you don't have a different front end and back end network, and simplifying the infrastructure and management and support. And basically, this would be, if you adopt this innovative stack, this will reduce your cost of your business and will increase performance, will increase reliability, and anybody who competes with your business that's using traditional SAN or hybrid all-flash array would be presenting or delivering lower quality service or slower service at a higher cost. So basically, you're having a competitive edge there. Here we show a diagram of a minimal deployment that actually is deployed in a number of companies. The slides are tailored around a specific deployment that's deployed in a Spanish cloud, and this is your starting config. They've grown, but this was like the system that they deployed when they started. And in their case, on the right side, they started with 5 compute nodes, which are virtualized. They're running a hypervisor, which in their case was KVM, and they're running virtual machines on top. In their case, this Spanish company is a cloud service provider, so they're running virtual machines to resell to anybody who is consuming cloud instances. These servers could be bare metal as well, but in this case, they're virtualized. On the left side, we had a StorPool cluster that started originally with 3 servers, just 4 SSDs per server because they had a low capacity requirement. So this is a shared storage system that consists of 3 storage nodes, that are running the StorPool software and have 4 SSDs. And this system is a standalone storage system that is presenting shared storage service to the hypervisors through a redundant 10 gigabit standard Ethernet network in this case. This is the whole system. It can scale both the compute side and the storage side independently of each other, and it scale out, everything is online in the system. Here we showcase the particular hardware that this cloud operator was running, and in this case they had a Dell R330 servers that were existing, so we were reusing those servers. They were very low spec, so very efficient in terms of cost. We are running single CPU E3 processor in this case. You can get the newer CPUs already available from Intel. We need just 32 gigs of RAM, which is something unique about StorPool, the level of efficiency that it has in terms of how little resources it requires. We have a 2-port NIC, so we have the redundant 10 gigabit network, so we have 2-port NICs, and HBA is basically the very, very common 31.08 Avago HBA host bus adapter. You can find it in most HBAs nowadays. It's just with flash firmware from different vendors. And the drives that we used are inexpensive SATA SSDs that are data center grade Intel 3510 in this case. There is a newer generation of these drives and other drives you can use from Samsung, from Micron, so you're not tied to a particular vendor. This is just what we had in this particular case. So this total storage system consists of 3 storage nodes, 6 times 10 gigabit ports, and 12 SSDs in total. We had network that is redundant 2 switches, quite inexpensive. Again, I think it was like $12,000 for the 2 switches. Direct attach SFP cables, which we recommend. We recommend, for example, on the network side, avoiding base T network just because it causes a lot of trouble. It works, but it needs a lot of babysitting. So if you're building a public or private cloud, we would recommend avoiding base T if possible. The client side, we also already mentioned, these were 5 servers. They were more powerful dual Xeon E5 processor in this case. I think we have a link to the full report with the performance test that we were going to show, so you can look at those later. So the StorPool software that's making the shared storage system is designed from the ground up. It's next generation data storage software built especially for the cloud era. It runs on standard servers, aggregates the performance and capacity, and delivers a shared bulk device that's standard. You can use StorPool. If you're not happy with our product, we don't lock you, and you're free to go to any other solution. We just make sure that we deliver a very good product, so our customers are growing and happy with the solution. Appears as a standard SAN to the hypervisor or the operating system. And the unique thing, really unique thing about StorPool is we designed it from the ground up to be very robust, so it's fully distributed, sure nothing architecture, state of the art. We haven't seen anything on the market that is good. And the magic is it just works. It went a lot of heavy work into this, a lot of hard work, 6 years, more than 6 years now in development, running at a petabyte scale. The single largest deployment is about 2 petabytes, 13 major versions. And unlike most storage software solutions on the market that have the same pitch, StorPool just works. That's a magical thing. It's simple and it works really, really well, really robust solution. The other unique thing about StorPool is the levels of performance that it gets in technical terms, like low latency, IOPS, megabytes per second. The levels of efficiency, this is how little CPU and RAM it consumes. So it basically saves your resources for running applications, virtual machines, etc. And also how robust the solution is. We have a small diagram of the architecture. And in this case, we have on the bottom, we have 3 storage nodes. It could be more, 5, 10, depending on how much capacity you need. these servers, we have visualized on the bottom a case where the storage system is running the StorPool software, but is also running a hypervisor like KVM or Zen in a hyperconverged manner. But you can have a standalone storage system as we showcased in the previous slide. In this case, you can attach a StorPool system to other ecosystems as well through iSCSI. If you're running VMware, you can connect to the same cluster through iSCSI. If you're running Hyper-V, you can do the same. Connect to existing shared storage solution delivered by StorPool that even is running hyper-converged on KVM or Zen, and then still expose shared storage service to a Hyper-V or a VMware server farm. In this solution, we are running tests on 12 SSDs. The tests were performed from 5 initiators, or the 5 hypervisor hosts that we showed in the previous slide in parallel. They're running on 500 gigabyte volumes. Performance is being measured by FIO tool, and the storage servers are running Linux kernel that's listed here, and StorPool version, that's the previous version of StorPool. But this was done earlier in the year. So these are the results that we want to show and explain how they have a direct result on your cloud. And here is the performance of the system in terms of IOPS. And this is this small system, just 3 nodes, 12 SSDs in total, delivered about 500,000 IOPS, random read, and about 250,000 random write IOPS. The megabytes is also impressive. We have about 3,500 megabytes per second, so 3.5 gigabytes per second sequential read, and about 2 gigabytes per second sequential write, which is impressive for such a small system. And these results are actually restricted by the number of hypervisors that are available in the system. In the previous slide, we showed 3 storage nodes and 5 hypervisors. So if you have 10 hypervisors, they will be able to get a better performance just because there is enough storage performance in the system, but there were not enough client-side workloads that would demand this performance to fully load the storage system. Here we have the metrics that are presented in a table with the performance that you've seen above. And these are the QDAT, like how many parallel requests we run to the storage system. Now, the next slide that we have is latency. And I think we cannot stress enough how important latency is for the storage system. While a lot of storage vendors would quote you total IOPS numbers of how fast their storage system go, you always have to ask at what levels of latency these IOPS are measured. So if you have to walk away from this webinar, and you have to remember one thing, is you have to know that the latency is the ultimate metric you have to look at when building a public or private cloud and you're measuring the storage layer, because this would have direct impact on your application, the quality of your service to end users, and how well these applications will behave, and also have direct impact on your hardware utilization. So you have a fast storage system with low latency. This will basically unlock compute cycles on CPU cycles on the compute resources. So basically you reduce your total cost of your solution just because you're optimizing the compute side as well if you have a low latency storage system. In our case, the small storage system starts at about 200 microseconds, like 2.2 milliseconds latency. And what is impressive about this graph is how latency changes as you push the system or you start hammering the system with I/O. And that's a very impressive graphic because it shows that for a single initiator, you can do 100,000 IOPS for less than 500 microseconds of latency. I think I have it in the other slide. Okay, here it is. Like, this is the table representation of the previous chart. And basically, here I have highlighted, this is random read write 50-50, so it's a heavy workload, and the system can deliver more than 100,000 IOPS, and the latency is less than half a millisecond latency, which is quite impressive for a storage system, especially for a very small, very low-cost storage system. And basically, this is the metric that says under relatively heavy workload, you would have extremely good latency. Actually, most of the storage systems that we have in production currently are peaking at something like 40,000, 20 to 40,000 IOs. So they sometimes, or they're not peaking, but they're doing 20 to 40,000 IOs on average. Sometimes they're peaking at 100,000 IOPS, 200,000 IOPS, but the average workload would be somewhere between 15,000, 20,000, 25, 30,000 IOPS. So they don't require that much IOPS, but the latency, anytime you can increase tenfold the latency, this is increasing tenfold the application, sometimes more. Because usually you have an application, let's say you have a website, this website has a stack in it that hits the database. Anytime that somebody comes to your website, basically they start hitting the storage system with request to load 100 elements of this website. So any image, any script that you have, any single visit to a website is translated to hundreds, sometimes thousands of requests to the storage system underneath through the database to load requests. So anytime that you have a storage system that can do 10 times lower latency, you're basically increasing more than tenfold your application performance. In this case, you can use this solution as a boilerplate to have a storage solution that's small, inexpensive. It can be the storage foundation of your cloud, and it can scale with it. And here are some of the recommendations we have if you think of building a software-defined storage solution and doing this the core of your IT stack. The first thing that we see a lot is companies that are trying to cut corners and try to run consumer-grade SSDs, and we would heavily discourage this. In our mind, if this is your business, you should invest in proper data center-grade SSDs. With StorPool, you can use inexpensive SATA SSDs. You don't have to run for SAS SSDs, but make sure you have decent SSDs. And the reason for that is data center grade SSDs have power loss protection and don't have throttling, whereas consumer grade SSDs usually have throttling, which basically limits performance to preserve the metrics that are quoted by the manufacturer, the endurance metrics of the SSDs or the wear metrics, and data center grade SSDs don't have throttling. They also have power loss protection, so in the case of power going out in the data center, you would have prevention. And a big point here is we hear a lot about people asking, why would you require data center grade SSDs that have power loss protection if my environment is in a data center? And it has 2 power feeds, it has UPSs, and it has diesel generators to back it all up. And as much as we want to have an ideal world where technology just works, the average thing we've seen is data centers going out every 2 years on average. As much redundancy there is, usually it's a human error, but unless you have basically design on the architecture, any level, not only on the data center level, on the IT infrastructure itself, storage, network, compute, and also on the application level, the more sophisticated design or the more robust design you have, that basically means 100% uptime or as close as possible. The other thing that we would recommend if you use this architecture is to use inexpensive single CPU processors for the storage system, which basically slash your costs and make your cloud more efficient in terms of dollar spent or return on investment, but also the single CPU cores are faster in gigahertz, so this basically means a faster storage system. The other thing on the compute side is to use powerful, usually 2-socket E5 or Xeon scalable processors and as much RAM as you can get, which would give you a higher VM density and better unit economics for your cloud offering. Another thing that I think we haven't listed here, but if you look at the product portfolio of the CPU manufacturers, usually Intel, you would have a point where if you get a more powerful processor, it will have better unit economics. It will have more cores, let's say 30% more cores, and the price premium will be only 10%. So if you want to optimize your cloud, you should go for a more expensive CPU, which has better unit economics. And there is a point in the price list where there is an inflection point where for the flagship, the very high-end CPU, just like have much higher cost compared to the gain in CPU, and we can help you with choosing the best hardware if you decide to look into this stack. Here we have a price performance efficiency metrics, just because you have to always overlook cost when you're building a cloud solution. And in this case, we're looking at this small system that we list here, that we showcase. It has about 8.7 terabyte usable with the 12 SSDs. And this can be more depending, this can be more terabyte logical, or the terabytes that are visible in your virtual machines that are available for your applications for a number of reasons. One of the reasons is this is a team provision system. So basically it can show more space to the virtual machines that's physically present in the system, and we also have a number of other space-saving features. So depending on your cloud management system, on your hypervisor, you might have from 2 to 5 times more space to give to virtual machines compared to how much hardware you need on the physical devices. This system was about $35,000 in total end user cost over 3 years, including the hardware, including the software, including the 24/7 enterprise-grade support, the SLA from StorPool. I think if you build it today, it's going to be maybe newer generation hardware, obviously, and it's going to be about the same price. You'll just have faster and better hardware, so this will increase the performance of the system. Obviously, this system, if you price this, those R330 servers, the system will be less expensive. The price per gig of this system is about $4 per gig and just 7 cents per IO, which is the lowest dollar per IO I've seen on the market. The system scales online in small steps. First step is just filling the other 4 empty drive bays in the system, which will double the capacity and will bring the price per gig down, just because you're obviously you have some economy of scale, you're using the same chassis. And by adding more systems, this system can scale in the petabyte range, and it can have millions of IOs available to the system. And with this design, we want to kind of get the message that with a little investment, now any public or private cloud can be better than its competition, not only on storage side, but compute reliability, level of quality of the service it provides, also reducing support tickets, time to market, cost for supporting customers, all these business metrics, just by innovation in the storage stack. And the other thing is, if you improve the performance, eliminate time, downtime, save cost. Before it was like a golden triangle. You can have 2 of the 3, but now you can have all the 3 benefits of better performance, better service, and lower cost at the same time. And basically, this means a better storage solution will lead to a better public or private cloud. All the performance metrics that I've shown, you can find them on the link below. It's on our blog, and there is more kind of information about the hardware configs of the particular test setup. And we also have a number of other price performance metrics or performance studies you can find on our websites, as well as other storage-related content. So I think with this slide was my last slide, and I would like to open it for Q&A.
Thank you, Bojan. That was really impressive, quite detailed, and I'm pretty sure that all the people at the webinar find it very useful. Just to summarize what we should do so that we can build a better cloud, the focus is on faster service. You need definitely to eliminate downtime, more features, and competitive price. These are the keys to having happier customers and better cloud. Just a few questions which we received on our email before the webinar. The solution you described, it's quite amazing, but is it available with servers from other vendors, or you need to use any specific hardware?
Okay, that's a very good question. And if you're using StorPool, we are independent of the server vendor, so I have a hardware compatibility list. That is per component. And since, for example, SSD drives are manufactured by 4 major vendors, 3 or 4 major vendors, and regardless of the server vendor you're using, most likely they're using OEM drives from either Intel, Micron, sometimes Toshiba, Samsung. So these are the usual manufacturers. So regardless of if you're using Lenovo or HP or Supermicro, Dell servers, or some other vendor, it will be one of the drives coming OEM from a big manufacturer. So this is the reason why we have a hardware compatibility list on component level, and you're free to choose any server vendor that you're using currently in your data center.
I noticed on your presentation that when you were describing the architecture, you mentioned the usage of SSDs. Does this mean that the system and the solution can work also with NVMe drives?
Yes. We currently have NVMe in production for, I think, about 9 months now was our first deployment with NVMEs. And we fully support actually HDDs, mixed configurations that are hybrid in SSD and HDD to give you all flash performance at lower cost because of the HDD component. And we also have NVMe drives with RDMA capable network, so you can actually utilize or harness the lower latency of the NVMe drives. You're free to choose depending on your performance needs and also on your budget, of course.
Definitely, the performance is very, very important. And you mentioned that the performance which was achieved by the system was almost 500,000 IOPS, right?
Yeah, it was about, I think, 468,000 IOPS. And it's limited by the number of hypervisors that were consuming the performance of the storage system. But safely, you can say that this system can deliver about 500,000 IOPS peak, which is impressive for a system that costs only $35,000 over 3 years, both software, hardware, and also it's very small and efficient system that can still grow in the petabyte range.
So should we understand that the performance is scaling out with the numbers of servers which are implemented in the system?
Yes, it's a scale-out system, meaning anytime you add more drives or you add more servers, you are increasing not only the capacity in the storage system in terms of terabytes available, but you're also increasing the IOPS. You're not changing the latency though, which is very important. So if you have 10 servers, this will increase the performance of the storage system, but would not impact the latency.
Thank you, Bojan, for the answers and for the presentations. If there are some other questions, we can answer them now, or if you have questions, you can email them to us, and we will publish the answers on our Twitter account or our Facebook page, and you can watch a recording of the webinar very, very soon in our blog. Thank you, everybody, for being here tonight with us, and have a great evening.
Thanks, bye.